Hi everyone. Now what I want to do is I want to take a second and explain truth trees to you, explain how they work, so that you know when you watch the next videos and I'm actually doing truth trees, you'll understand what it is that I'm doing. Truth trees is a really quick, handy, easily understandable way to test for validity. Remember our definition of validity. Arguments are valid, not statements. Arguments are valid or invalid, and actually, to be more precise, deductive arguments are valid or invalid. So when we're checking for validity, we have an argument up here. What we're asking ourselves is it possible for these two premises to be true at the same time that the conclusion is false? If that is the case, then this is not a good argument. That means that this would not be true because these two things are true. In order for an argument to be valid, it must be impossible for the premises to be true at the same time as the conclusion is false. Truth trees are a way that we can use, a quick, handy way that we can use to determine validity. And we're going to use the definition of consistency to test for validity. Understanding the two of these is obviously going to be very important. If you have questions, post them on the discussion board. This is really, really important. So, here's what we're going to do in order to test for validity. I've already symbolized my argument into this form, into symbolic form. The argument says, if P is true, then Q is true. If Q is true, then R is true. Therefore, if P is true, then R is true. Right? We want to know if that argument form is valid. Is that a valid argument form? How would we check that with truth trees? Well, what we would do is we would assert the premises as true. So when I say I'm going to assert the premises as true, I'm just going to write down the premises exactly as they are, and this is now asserted as true. This is asserted as true. And then I'm going to assert, notice how I do this using the definition of the tilde, I'm going to assert that the conclusion is false. So I'm going to list the premises as true and the conclusion is false. And then I'm going to check to see if all of these statements can be true at the same time. A set of statements is consistent if those statements can all be true at the same time. A set of statements is inconsistent if it's impossible for those statements to be true at the same time. Notice what we've got here is the assertion of the premises as true and the conclusion as false. Here's the premises, there's the conclusion. I've asserted the premises as true and I've now denied the conclusion. I've listed the conclusion as false. If these three statements are consistent, that means they can all be true at the same time, then it is possible for the premises to be true when the conclusion is false. That means the argument's invalid. If these three statements are inconsistent, that means these three statements cannot be true at the same time. If these three statements cannot be true at the same time, then that means it's impossible for the premises to be true when the conclusion is false. We have a valid argument. So that's what we're going to do. I've got other videos where I actually work through some truth trees for you, and in the lecture I work through one. It's probably more difficult to follow in the lecture. If you watch the ones that I'm going to do, that I do in the next videos first, then you go back and read the lecture, read it very carefully, making sure that you notice step by step what I do. It should make sense, and this is it'll open the door and it'll be very easy for you. One more thing. As I work through the truth tree, there are a couple of things you need to know. One, I'm going to be working vertically. These three statements I've listed as true, and I'm not going to change the truth values of those statements. Instead, using the rules of the logical operators, see the other videos, using the rules of the logical operators, I'm simply going to unpack what are the conditions that are required for this statement to be true. Well, this statement will be true. I'll go ahead and give you the answer for this one. This statement will be true when either the antecedent is false or the consequent is true. When either the antecedent is false or the consequent is true. I've now listed the antecedent as false, just like I did with the conclusion. I've listed the antecedent as false, and I've listed the consequent as true. So I'm going to put a check mark here to let myself know I've already done that one. But now looking at this, I want to explain how to interpret this. What this says is that there are two different situations where this statement would be true. This statement will be true when either P is false, the antecedent is false, or the consequent is true. So what this tells me when the truth tree branches is it tells me these are two situations now, two entirely separate situations that I'm working under. I'm now working under the assumption that it's the antecedent that's false, and I'm now working under the assumption that the consequent is true. Let me erase my definitions here, and I will explain this just a little bit further. By contrast, I could do this one next. The order doesn't matter, but I want to do this one so that you can see how this works. I'm going to check this off. Under what conditions would this statement be true? Because all I'm doing is unpacking in terms of truth conditions. Under what conditions would this statement be true? Well, this statement with the tilde will be true when this statement is false. Remember from the prior lecture, if I have the statement P, if P is true, then tilde P is false. And if P is false, then tilde P is true. So what the tilde tells me is to flip the truth value of the statement to which it's appended. Well, using that, this whole statement will be true when this statement is false. And what's the rule for the conditional statement? A conditional statement will only be false when at the same time the antecedent is true and the consequent is false. So the way I express at the same time, both those conditions must be met for this to be true. In order for that to be the case, P must be true at the exact same time that R is false. So when I stack instead of branching, I'm saying both these conditions must be met. This tells me that either or, this tells me that both of the conditions must be met. And notice when I'm interpreting in terms of truth values down, I must list under any open branches. So I've got to bring it down under both of these two scenarios because this tells me these are two independent scenarios. Now what I'm going to do is I'm going to check to see if there are any contradictions. Notice this. This is kind of fun. Notice that here I've got P asserted as true, and here I've got P asserted as false, right? That's a contradiction because P can't be true and false at the same time. So that branch now closes. I'm not going to work with that one anymore. When I made this first assumption that P was false up here, I ran into contradictions. So that's not going to work. Now I'm only working over here. And what I would need to do at this point is go back up and unpack this one. Unpack this statement. Under what conditions would that be true? Really quickly, that would be true when Q, the antecedent, is false or the consequent is true. Notice I've got R and not R here. That closes. Here I've got not Q and Q. So that closes. To check to see if a branch closes, you're going to work up the hill. Now, I'm doing this quickly, I know, but in the subsequent lectures, I go nauseatingly slow. I'm serious. You can get up and go make an omelet and come back, and I'll still be working in the same truth tree. So the one thing, that's the phone, sorry. The one thing that I want to point out here is this. I started out by assuming the premises were true and the conclusion is false, and I ran into a contradiction wherever I went. What those contradictions tell me is that these statements cannot be true at the same time. That tells me if the premises listed as true and the conclusion is false can't be true at the same time, then that tells me that this argument that the premises can't be true when the conclusion is false. That means that this argument is indeed a valid argument. Okay, watch the rest of the videos and post them on the discussion board if you have questions. I can definitely create another video responding to your questions if need be to explain the specifics. You need to be active on this as we move into this component of the class, and you need to make sure you ask the questions. Don't let this slip by, okay? I'll talk to you later.